Hey everyone, I'm Nathan. Um, some of you know me, some of you don't. What we're going through today is a little bit of a lunch and learn topic around a practical introduction to APIs for non-developers. Generally speaking, I find non-developers find APIs quite difficult to understand because generally the assumption is it's a very, very technical piece of information or technology that doesn't really make sense to the broader audience usually. So the purpose of this whole session today is to try to shed some light on why APIs aren't entirely technical, trying to enable people to look at APIs a little bit differently and maybe understand a little bit about it. So then that way they can go and have a chat with a developer about something a little bit more specific around APIs rather than trying to go through onboarding of what an API actually does. So Esteban, I get you to switch the screen. Next one. Cool. Actually, we'll go back. So this is just an example of our purpose and motivation. So today we're spending a lot of time in a slide deck and just kind of talking about this stuff. We got some examples that we're going to be showing you through like pictures or diagrams, as well as demonstrations from Esteban. In addition to that, we built a bit of a Confluence page around APIs for non-developers, which explains a lot of this information a bit more in depth. Of course, it's a living document kind of thing, so down the track, we'll update it, modify it, depending on like how much engagement we get from people as well. So if you've got any suggestions for improvement or feedback, let us know. So I'll just kind of go through this part of the screen right now. So the big thing that we're trying to do here is joining the worlds between technical and business with APIs. With this, we have a goal that we want to meet with non-developers can start to understand what an API is, what's in the API, and how their business or team could benefit from it. In addition to that, it's worth noting that devs generally focus on the implementation of an application using APIs or developing the API themselves. The fact that it's an API doesn't actually mean it's entirely technical. At the end of the day, an API exposes business functionality to be used. So here's a little picture of the 5 key concepts that we're going to be covering around APIs, such as what is an API, how to understand it, authentication, authorization, and API keys, how to find an API, and how to consume that API. So we'll have little live demos throughout this. We've got another slide deck just with like URLs and all that. So when we send it through afterwards, you can scour through the slide deck easily. So what is an API? At its very core, APIs are a way for applications, so like a mobile app or a web app, to communicate with other applications or servers on behalf of the human being. The human in this case is a user of an app. Or other servers to communicate with each other in a structured way. So this is like behind the scenes of a business, systems to systems, APIs to APIs, communicating to each other to send or transform or mediate data and so forth. Basically, APIs are an interface for 2 or more applications to communicate. And there are a few different types of APIs, but for the purpose of today's session, we're focusing on web APIs, predominantly the REST architecture. Web APIs are a way for one application to expose business functionality to be consumed by another application through what's called a HTTP protocol. So we'll explain that a little bit shortly. One thing also worth mentioning, API stands for Application Programming Interface. But 9 times out of 10, people just call it API. Cool, so I drew up this little screen to try to give us a real-world example of where an API can be used. This is a purely hypothetical scenario. It's just to try to understand where requests and responses are coming through and where APIs can generally sit. So in the little orange boxes along the top, we've got ATM user, which is Bob. So that's our user. We have the ATM machine, which is like an application. Then we have the bank, which can be an API, and then the authorizer, which can also be an API. So we've got Bob over in the left-hand corner. He wants to buy some things, but he needs $100 to do so. So he wants to go and find an ATM machine, and then he inserts his card and enters a PIN. The ATM machine has received the card, received the PIN, but it doesn't know what it needs to do with that. So it sends off a authorization request to the authorizer, which can be like an API request at that point. The authorizer then verifies and validates the card and PIN number and sends a response back to the ATM machine. In this case, a 200 or an OK, which is like a successful message. Bob is allowed to access the account on this machine. After that, Bob is at the machine itself and he does some prompts to withdraw $100 from it. So then the ATM machine validates the balance with the bank, which can be done through the form of an API request. The bank then can check if the account has $100 in it, or basically the balance. And then it can send another request to the authorizer to authorize this withdrawal. And then we send back a response through to the bank. And then the bank sends a response back to the machine, which then says the machine is allowed to dispense $100 to Bob. Then the money comes out of the machine, and then he grabs that cash money and it can go shopping. So that's kind of like a real world example of where an API can be used, and where there's requests and responses to validate and authorize information as well as send information. As you can kind of see through here, an API is a way to transact like communication between applications and servers and so forth. Cool. So the next step is, where does an API actually fit? So APIs are effectively proxies or gateways between a business and a user. An API can offer an interface for users to say, hey, I want to get some information from your system. Here's my identity. Here's the kind of information that I want, as well as how I want that information. So the API understands that request from the person, then sends that request through to a web server and a database, gets the data back based upon that information, and then sends a response back to that user or the application itself. Cool. So we're up to HTTP protocols now. So I might hand over to Esteban to explain this next section. He might show you a demo of how this actually works in terms of a request and a response. And then we can come back and talk a little bit more about some other stuff.
Hello, everyone. So, yeah, we need to go a little lower in level here because it's very important to know what the HTTP protocol is in order to understand web or REST APIs. But even if it can get a little complex, it's not so complex to understand at the end of it. So what's HTTP? HTTP is basically the protocol that powers the web. Every time we browse the web, almost everything that happens under the hood is HTTP. So when we go to Google, when we go to any page, when we click a link, when we submit a form, everything under the hoods is HTTP. So we all, every day, all day almost, use the most well-known HTTP clients, which are the browsers. So the web browsers are basically HTTP clients. Everything when we use the web web browsers under the hood just do HTTP requests and get HTTP responses. And there are not the only HTTP clients out there, but are the most well-known. So yeah, let's look a little here. What is it? So every time, like, let me open this kind of tool that let us see what's happening under the hoods. When we go to Google, the browser just do a request to a server using an HTTP, the HTTP protocol, and get the response back from the server. We'll take a look a little more at this, but it's a record response. Like when we press here, if there's a HTTP request going to the Google server, and the Google server returning an HTTP response.
It's just worth noting as well, like a HTTP response, it's not always just displaying a website. It can be a set of data that it's sending through to you. It can also be like verifying your identity. In addition to that, yeah, it's just basically it, really.
Yeah. And this is not the only HTTP client like out there. For example, you may see some of your like teammate engineers using some other like kind of obscure HTTP clients. This is one of them. It's called curl. So it's a command line HTTP client. So I can also do the same request to Google the same request that the browser is doing and get the raw response from the server. And this is not the only one. wget, for example, is another very common one. So wget, google.com. In this case, it doesn't show me the response out there, like there in the screen, but it saved it to a file. The same thing that the browser is doing. So why do you see your like teammate engineers using this? Because these things are like Swiss Army knife tools for HTTP. So we can tune it, like we can set a lot of configuration options and it helps us debugging, seeing what's going on under the hoods, and also it's a command line tool, so we can use it to automate stuff. So we can use it inside scripts and all of that. And also, like something like good to know, for example, this is so well known that if you like the Google Developer Tool, for example, lets you export any request as a core command or others. So you can go find a request, copy as core, and repeat it in exactly the same way here, the headers and everything. So yeah, when you see us like trying to do this, it's the same thing that the browser is doing, just another way of doing it for like different purposes, but it's the same stuff.
Nice.
Perfect. So as we saw before, it's like a request response protocol. Want to show this one?
Yeah, sure. So basically, as part of like sending messages through to an API and receiving stuff back, we call them HTTP requests and HTTP responses. Basically, a HTTP request is a way to request some specific data via an API. For example, get doggos where they are not cute from, then a version of the API, v1, then the API itself, pets, and then the resource dogs. Then we have a question mark, which is basically passing through some parameters or characteristics around what we're trying to get from that API, such as we're not cute as a value. Then we have a HTTP response, and basically those are a response from the API with a status code. Depending on that status code, you may get a payload of data with it as well. So in this case, since we queried the pets API, trying to find all the dogs where they're not cute, we get a 404 because none of that can be found because there's no cute doggos found, really. So that's kind of like an example of a request and a response that you're going to receive. Try to think of it in terms of like basic English at the end of the day, but you're just adding like another layer on top of that to talk to the API itself. At the end of the day, you're just really asking a question and you're getting a response for that question. Cool.
Mm-hmm. Same.
So is that like hit and hope? Like, is that real world, or did you just come up with that? Or
oh, we just came up with that example just to kind of show it in plain English.
Yeah.
But real world examples, we'll kind of get to that a little bit later. Yeah.
All right. So the HTTP requests have different parts. Maybe let's not go very deep into these, like a URL, a method, headers, and a body. So there are different types of requests. There are more than that. This is just only 4 of them, but this is the most well-known type of request. So get is the one that we just saw. Like we want to get something, just obtain it. So when we go to Google, what the browser use is a get request. So get me this web page. Post is when we want to create or update something. So when we use a web form, usually under the hoods, there's a post or a put because we want. So when we fill a web form, so most of the time we want to create something, create a transaction, create a client. So under the hoods, post and put. Sometimes there are others like delete and some others. But as Nathan said, try to interpret it as is, like as in English, like because that's the way it's supposed to be. Like
yeah, absolutely. And like get, post, put, delete also kind of relates to the CRUD acronym. Create, read, update, delete. So create is post, read is get, put is update, and delete is delete. So that's just a kind of simple way to kind of think about a HTTP request in this sense.
Yeah. So elaborating a little more in the previous example, let's go in. Where's my mouse? Here.
There we go.
Yeah. Maybe let's use a real mouse. Let's go and see a very, very simple web page. This is just content, like text and images. So this is a very simple web page. So what are we saying here? Like, okay, I want to get this page or file from this server, of course, using the HTTP protocol, which is in this path. It's basically it. So when we do this, what happened under the hood is, of course, like the web browser submits a GET request for this file. And it also submitted a GET request for this image. Why? Because in the source code, at some point, the browser finds like there's an image. So the browser says, okay, so I will also do a GET request for the image. So all of this is GETs because we are trying to, the browser is trying to obtain information. So it's just pure GETs. And usually when we submit a web form, what happened under the hoods is can be a post, can be a put, can be a delete. It depends if like the purpose of what it's trying to do.
Yeah, what action you're trying
Exactly.
to make, really.
So if you look at the network tab here and you submit, you will see most of the time you will see a post, the method post. And I didn't display that too much, but the post usually sends a body to the server, and we can see the body, the payload, what's being sent here. So what is being sent is the fields that I declare in the form, and they are just sent in this kind of format, which is just this. The field, the value, ampersand field, another value, ampersand field, another value.
Yeah.
But this is it. It's not more complex than this. Like, don't try to like. Is this just this text? That's what's being sent in the wire. So
That's
it. Yeah.
Nice.
Perfect. And responses also have some parts like starters, headers, and bodies. But the important thing here, one of the most important parts, is like the response has a code, a status, a number, and the numbers indicates what's really happened with the response. And most of the time, the one we happily, like the happy response code is 200 because it says, yeah, okay, the resource is there, take it. So when we go to Google or in this very simple page, for example, most of the time, when what we see here, the response is the 200. 305 is also happy because it says, it's kind of, the browser says, hey, I request this page 2 minutes ago, still the same? And the server says, yeah, still the same. I won't send it to you. So it's like, okay, it's called not modified. So it's like, yeah, it's still fine.
It's kind of like stored on your computer already, and there's no real reason to update because there's no changes.
Yeah. So successful are under the 200 range, and redirections or cache or something like that under 300. 400 is like, is the client's fault. The client did something wrong. So for example,
Client bring the browser or the application in.
yeah. For example, a request no or not here, so it doesn't exist. Now it should get a 404. And 500, so this is my fault because I requested something that's not there. But and 500 is the server fault. If the server, for example, run out of memory or has a programming error and handled, something in this range will come up. Yeah, so that's mostly it. Let me probably show you. This is just like, just to kind of demystify all this. We can also, like, for example, even if we don't have a browser, we can do an HTTP request, for example, at hand. So I'm just establishing a connection to Google here right now, and I just at hand, like, writing the HTTP request by hand. So get whatever is on the root, HTTP/1.1 the version, and say host google.com, enter, and I got the response back. So it's pure text going back and forth. Oh, disconnect. Okay, perfect. All right, and like what we get when we interact with a web page is usually a mix of HTML, CSS, which is kind of HTML is like the structure of the web page, CSS is how it looks, and JavaScript is like dynamicity in the page. But this is what we receive in the body of the response of the request when we browse the web page. Oh no, lost the.
There's another tab.
Is it?
Okay.
Okay. Perfect. So yeah, we just ask for the resource and get the HTML back, but not always, or doesn't necessarily need to be HTML. You will see that a lot of times when you submit a GET request, you can get something like a JSON, and JSON is just the data itself. So JSON is nothing that, okay, this is a web page which looks like this and all that. JSON is just the plain data with a human readable format that looks like this. But under the hood is the same. So if we go here, for example, and go and visit this website, remember, it's always the same, a GET. What I'm getting here is it's not a web page, it's not HTML, it's not something to be rendered by the browser, it's just data. So it gives me one field called the fact. So all cat has this and that, and the length of the field. It also looks nice because I have an extension, but it's not supposed to look nice because the browser doesn't really know really what to do with that. It's just text. So you go to look like this. So why this come into place? Well, this is when we start getting into web APIs. Like what we get from the actual resource or server is not a web page, but data. And this is where APIs start getting into place. This is just showing you that the web is mostly those things that we saw before, the HTTP protocol, but the rest of stuff there.
Awesome. Cool. Thanks for that, Esteban. So I'll take over this next section, which is talking about web API protocols. So a web API protocol determines exactly how you interact with an API. For example, the formats, the structure of the data, the network protocols behind it, what parameters, headers, all that kind of information an API can contain, and the structure of that. Aside from determining how to interact with that API, it also helps determine how to build the API through that standardized architecture and structure imposed. Some of the common API protocols that you're going to hear mostly about, which is REST, which is a web API protocol. You might also hear about GraphQL, which is basically a way for a user to get everything from the API, but also form a specific request around that and basically get a response. I found in my personal experience, GraphQL is generally used for reporting purposes, so you can build dashboards with it and all that kind of stuff. Then we have SOAP, which is kind of old and a little bit archaic. Effectively, all it really does at the end of the day is it is an API, but it's constrained by the XML structure. So in terms of that, we generally convert like SOAP to REST APIs in other API-based engagements that I've worked on. And then we have gRPC as well, which is a little less known, but it's also system side. For the purpose of the session, we're purely focusing on REST APIs. So REST, in very practical terms, is using the rationales behind the web architecture to implement web APIs. A REST is a standardized structure of constructing an API and typically has a few core concepts that make calling the API a lot easier, such as HTTP verbs, which is get, put, post, delete, which we covered beforehand. This is how you're requesting from the API. Then we have sensible resource names, which is what you can get from that API. And then we have HTTP response codes, which is the status of your request from that API, which is like your 200, your 404s, all that kind of stuff. Here's a little explanation around the HTTP verbs. Not really going to cover it too much because we've covered it before, but this is a specific definition on how it's used within REST. Here's some sensible resource names. So what we can see on the screen right now is a API specification. particularly a Swagger render of that specification. This is off a REST API. So on the left-hand side, you can see you've got get, post, get, delete. They're your HTTP verbs. Then we see a /store/inventory. Store in this case could be a resource or an API, and then inventory is a resource. So I'm having a look at the pet store. I want to see the inventory, and then I can request some specific details around that inventory. In addition to that, you've got post, so store order. In this case, we can use this section of the API to post a purchase order through to the pet store through an API, rather than having to call up over the phone or whichever. You can do it directly with an app or within a browser, for example. In addition to that, you can also get purchase orders. So you might have like extended fields within that Chevron segment where you can get the order by the order ID, but you might also want to filter it down by a specific customer or a specific item that may exist on the order and so forth. And then you got delete, which is deleting the resource based upon your characteristics that you pass through to the API, as well as authorization and all that kind of stuff. Here's a list of HTTP response codes, which indicates the status. So these are the most commonly experienced ones. You've got 200 OK, which we've seen a little bit. We got 201 created, which is when you're doing a post or a put and it's successfully created or updated that resource. You got 204 no content, which is basically it. The request was successful, but there is actually nothing inside the response itself. So there was no data to send back, for example. Then you have 400 bad requests. So that is, for example, passing the incorrect parameters, passing some incorrect values. Basically, your request isn't formed properly. And then you have 401 unauthorized, which means that you haven't passed any authentication or authorization to that API. So basically, the API doesn't know who you are, so it's not going to give you data. So we got this screen, which, Esteban?
Yeah, like what I'm trying to say here is like the same thing that we have been talking about before in the web is the same thing that powers REST APIs. Same protocols, same stuff. So in this case, for example, a web page can use this get client one endpoint to get information for the client, but also an application can use the same stuff to get information for the client. So it's the same things.
Cool. So we've gone through what is an API. Now we're going to go through how to understand an API. So in order to understand an API, you must first become an API. With this, it's basically really focusing on that API has documentation, API has specifications, and those documents and specs live somewhere on the internet. They can generally be found via API portals, or if you Google hard enough, you might just find the actual specification itself, which will tell you how to connect to that API. So with this, these are the different types of API documentation and spec standards that you have for the different types of APIs. So for our REST APIs, our documentation and specification standard is OpenAPI, or also known as Swagger. This is a common method of creating API specs for REST APIs. Then for GraphQL, the documentation and spec actually exists within the GraphQL schema itself. So you can basically go through the schema, understand what is basically making up this GraphQL API, and then you can form your requests based upon that. For SOAP, we've got what we've called these WSDLs, or WSDL, which is an XML-based document describing what the SOAP interface can offer. And then gRPC, which uses protocol buffers to be able to define the actual spec itself. And also describes like the service interface and the structure of the payload messages that you might expect. So since we're only talking about REST, we're going to go through OpenAPI or Swagger. So there's multiple ways in which a REST API can describe its interface. The most well-known is OpenAPI. It's a very standard way of defining REST APIs in terms of documentation and specs. The OpenAPI spec, formerly known as Swagger spec, is an open source format for describing and documenting APIs. The latest version is 3.0, and OpenAPI definitions can be written in JSON or YAML. So here's a YAML example of an API specification. As you can see here, it's plain English at the end of the day. You got OpenAPI, which is the version, some info, then version, title, which is sample API. So this is a sample API. a little description about that API, and then the paths. So if you remember from the previous screen where we saw like get, post, put, delete, and then like store inventory, store orders, and so forth, this parse creates the list for that itself and also defines the information that goes within the sections as well. So aside from just knowing that you can get all inventory from the store, it tells you exactly how you can do that or what specific information you can get, as well as giving you an example that you can try within the UI itself. So this is a Swagger UI example. So like mentioned beforehand, you got little chevrons on the right-hand side, which you can click and expand on and see a lot more about this segment within the API itself. Guess you kind of did that.
Yeah, all right. So cool. Let's go back to, where is it? To our old friend, the cats. Okay, not yet. Here, where is it? This URL that gave us facts about cats. This is effectively an API called the Cat Facts API. Why I can access the API through a browser? Because it's just HTTP and it's a GET. But when you, like, you know that there's an API here that has an endpoint that returns fact, but when you want to build an application on it, you want to know exactly like, okay, is it always these two fields? What's the type of the fields? Like, does it always give me a length? Does it give me more fields, less? How can I search for different kind of facts? Like, how do I know? Like, I only see that return. Like, so that's when the specification comes in. In this case, this is the specification of the CAT API. So this is where you can go and see what really does that API offer and how can you call it. So in this case, this CAT fact API has three different operations or functionality. One that gives you one fact, another that gives you a list of facts, and another one for reads. So right now, what we're doing here is calling with, and we can only see that it only has gets. So it's kind of a purely informative API. It doesn't let you submit new facts, doesn't have a post, doesn't let you edit the facts, it's just purely informative. We can only get stuff from there. So in this get, this get fact is this one, get fact. And if you want to know exactly what's being returned there, so you expand here.
Wow.
Yeah.
I think it's so big.
So you can the head of like my 13-year-old here.
Yeah.
So if you want to know exactly what the API returned, like what the format or the fact, you expand here and you see here the response. And the response has an example or has the schema. And the schema tells you how many fields, if they're optional or not, and the field data type. For example, the fact is a string, the length is a number. So here you have formally what the API, what's going on. And for example, I can call the other, which is facts.
As well.
So let's see. Yeah, facts. So give me a list of facts. Yeah. And like I can put a limit there. So they offer me in the parameters, they offer me a limit. So I can put here, for example, a limit equals 5 facts. And yeah, I can get 5 facts. So this is where you know what's going on in the API, and they have breaks too. So breaks. So under the hoods, this is that textual. Under the hoods, this is just this text that was shown here, but we don't like to just read that text just plainly because it's boring and you need to know everything. So we usually use a viewer. So this is like the most well-known viewer, which is like kind of the official OpenAPI viewer. So get used to this because most of the time you will find this viewer, hopefully. So this is another example. This is an example pet store API, and this is the Swagger or OpenAPI documentation. This is more complete. So this is a whole pet store. So for example, they offer functionality for around the pets. You can create a pet, update a pet. You can get pet by status, by ID. You can update a specific pet, delete pets. Also the store itself, you can get the inventory, you can post orders and handle the users. So this kind of more realistic one that offers like not only informative things, but also transactional operations. So yeah, and usually these are the colors that are used. So also get used to the colors because it's almost the same stuff, like green for these, blue for these, and all that. Oh, okay, let's go on.
Cool. So the next section that we're going to briefly go through, because this is a bit of a hornet's nest, is authentication, authorization, and API keys. So authentication is basically telling the API who you are. So I'm Nathan, and I want to speak to the API. The authorization is the API determining what you're allowed to access. So based upon that identity, you've got certain permissions that may be associated with it. And basically the API is saying, cool, Nathan as the identity can have access to these parts of the API itself. Someone who might have like elevated permissions or a higher level of registration can access other areas of the APIs, or they can access like specifically private or secret APIs and so forth. So that's authentication or authorization in a nutshell. Auth is who you are. Authorization is the API telling what you can access. So this section is really light on and is only focusing on what different mechanisms they are with authentication. Auth entirely as a concept can be a much larger topic depending on which company you might be working with. So for example, working with the ATO, a lot of our sessions have been around authentication and authorization. What are we going to do with the API keys? How are we going to solve these security issues and various other elements? You might have other businesses that you might work with that might be a little bit more lax on security. So at the end of the day, they might offer their users like basic auth, which is like, here's my client ID, here's my password, which is kind of like a username and password, and allowing access based upon that. So in this next screen, there's 4 common authentication mechanisms that I've generally come across in most of my engagements. So basic auth is effectively building to the HTTP protocol, but it's a client ID and a client secret, which is username and password style. You can use that basic auth to call an authorization API to be able to get a token or a key back to then call other APIs, or you can use it directly to call a specific API. In terms of what authentication mechanism is used when, it really depends on the API and who's developed the API. And you can find that information inside the documentation or the specification usually. There's generally speaking, depending on who's built that API, is a section around how can I get access, or how can I get credentials, or how can I register, and they'll explain the usual process around that. Another authentication mechanism is API access tokens. So this is like a unique identifier for every time you try to authenticate with that API. Applications used to make API requests on behalf of a user in this case. So we can pass a token and say, hey, I'm an application. I'm working on behalf of Esteban, which is a user. Mr. API, can I get some information from you on behalf in that case? So we can send through a token. We then have OAuth 2.0, which is an industry standard protocol for authorization. This is a mechanism for the client to send their identity information securely without the receiver knowing that sensitive information. So if you've ever used websites where you've had to log in with Google, such as like at Just HR Systems or Harvest and so forth, you log in with Google, have a look at the URL. It says OAuth 2.0 in it, usually. So with that, you can choose which account, and you're only speaking to Google at that point. You're not talking to Harvest. Harvest has just sent a request to Google to be able to prompt for your identity. So you then log into Google using your identity. Google then passes back a token or an authorization response back to Harvest, and then Harvest knows, okay, cool, we got Nathan. He's told his identity to Google. Okay, now we can allow him to access Harvest and log timesheets, for example. So OAuth 2.0, very commonly used. Same thing applies with Facebook and Amazon and all that kind of stuff too. And then last but not least, we got SAML, Federated Identity. So SAML stands for Security Assertion Markup Language. It's token-based authentication method, which is used in environments with single sign-on. An example will be using like Active Directory Federated Services accounts, or ADFS accounts, to authenticate through a single sign-on portal to call an API. A lot of businesses that we work with, they've got single sign-on pages that we can jump into. We pass our identity. We're then shown a list of applications we can get access to, and then we can choose that app and go through. So SEML kind of fields that SSO front level to identify the user and pass that information through to call an API. So yeah, as you can probably see, authentication, authorization, API keys can be a very loaded topic. It's probably a topic for another day that we could probably do a session on or something like that. So one of our last sections that we're going to be going through is how to actually find an API. So you might be asking, where do I actually find APIs and their documentation and or specs? Well, generally the most common answer is through Google, which may result with an API portal that might host an API, or the API spec, or with basic info on how to consume it and so forth. In my experience, like integrating like harvest data into spreadsheets or doing other work into spreadsheets and all that kind of stuff, as BA, I love spreadsheets kind of thing. And I've gone and Googled Harvest APIs, for example. They have an API portal. I can have a look at all the different APIs that they have on offer. Then there's documentation around it and specifications, so I can see what each API offers to me. And then there's been sections on how to authenticate and authorize. So API portals are generally very helpful with finding APIs and understanding those APIs. But in addition to that, not every business who has an API available to the wider world doesn't have an API portal. You can find this information online through Google generally, or if you're working with a business and you're doing work with their APIs, generally those APIs are private. They're hidden behind the scenes. They're not publicly available through Google. So you've got to speak to the right people within the business to get that information. So let's talk a little bit more around API portals. So API portals are a common way for API users to discover and understand APIs a business may offer. Typically, API portals will have catalogs within them. So it's kind of like a shopping site, really, with some documentation on it, in which you can then search, filter to find your desired API. Once you find an API you might want to consume, the API portal will display documentation and everything to know about the API, ranging from business info, specs, authentication, authorizations, and specific conditions and limits for the API. For example, you might only be able to call the API 10 times an hour with a basic level of authentication. Or you might have some security terms and conditions that you might need to sign up and get approved for to be able to get information, get your identity to be able to call this API and so forth. So API portals can show a lot of this kind of information. Some API portals can offer a self-service mechanism to register an account and register specific details to obtain your API keys and credentials to call an API that you might register for. So here I've got some examples of some public API portals that you can literally Google right now and go and have a look and see what APIs I have on offer, understand the documentation, maybe create an account, log in, register, all that kind of stuff. Yeah, of course, the first one, API portal, that's a DSH engagement. New South Wales Gov API portal, we've used that as a little bit of inspiration in the past for how to design the site and what kind of information you can get. This is really helpful because it's publicly available information from the New South Wales government, and you can get like fuel data, for example, and build a fuel-based app to check prices and all that kind of stuff. Then you got the Harvest API portal, which I've used a bunch of, and then you got a Zero API portal, which is really well defined and really well done. So last but not least, version 2, how to consume an API. So there are a couple of ways APIs are consumed, either directly to interrogate an API or via an application on behalf of a user to service that application. An example of an application on behalf of a user is, say, when you open up your weather app and you're wanting to get the current weather right now, the weather app is sending an API request on behalf of you to BOM to get today's weather for your location, returns that through a response, and then your application renders that response into a nice UI, and you can say today is cloudy, 21 with a chance of rain, kind of thing. Cool. So with consuming that API, Esteban's going to show us how to call an API using Postman. Before he's shown you how to do a simple basic call, a simple get through your HTTP client, which is a web browser. But this one is going to allow you to do some other things, such as get, post, put, delete. You can actually interrogate the API a little bit more. You can pass different information to it. It's got a nice UI that kind of wraps everything around it, so it's a lot more intuitive. As a non-developer, it's a very handy way to understand what an API can give us in a live world. So then that way we can speak to devs a little bit more around how we can use that information and so forth. So before you can call an API in this case, there's some prerequisites or a little checklist or a little sanity list that you might want to go through, such as you've obviously found an API. You've understood the API documentation if it's available. You've obtained the API URL from the spec or the doc. You've obtained credentials to call that API, so generally through the API's API portal or the service provider or the business that you're working with. You've also downloaded a tool to call the API, for example, Postman. So once you have the above, you can generally consume an API at this point. We got a few more extra tools around calling the APIs, such as Postman, then Newman, which is a command line interface for Postman. Then we got curl, which Esteban showed you a little example of before. So with Mac, it's Unix, or you can use Windows CLIs for that. We've got a couple of open source options, such as Hopscotch and Insomnia. And obviously, you can use your browser for simple gets. So if you don't actually require any authentication, you can just paste the API URL into the browser, see the response. I also got a little handy video on how to configure your first API request using Postman. I'm not going to play that now, obviously, but when you receive the slide deck and the Confluence page afterwards, you can have a look and play around. So I'll hand over to Esteban for a final bit.
All right, let's try to make it quick. 5 minutes
Let's do it.
or less.
Easy.
Cool.
Yeah, do it.
I actually don't remember which was the one that was.
So pet store API one, isn't it?
Is it?
Yeah.
All right, cool. So let me get the Swagger spec. Oops, it's a good one. All right.
Yeah, demo gods.
All right. Yeah, Swagger now. Other ones that's get play by create pet. Perfect. Yep. All right. So let's get a pet ID and let's create a pet. All right. So we have the specification. We know that what we want to do. We want to query pets and we want to create pets. So most of the time you get the. Okay. Sometimes you can just use it here. So sometimes this thing you can try it out, and you can just fill the data here, the parameters, and the name, Scooby-Doo, and the status. I don't even know what's this. Status that of pet that needs to be updated. Okay, I guess. I need execute. Look, it gives me the curl just in case I want to repeat it in my command line or whatever. And photo 4, white. Why? Can parse JSON. Pet not found. Okay, I'm updating a pet, an existing pet. Yeah, that pet doesn't exist. I don't know. I don't even know what the ID is there. So let's, yeah, updated some pet, which was not mine, sorry. It was the pet number 2. It was a cat, so I put it as Scooby-Doo. Yeah, that's a good brain name for a cat. So yeah, sometimes you can just test it here. That's it. You don't need anything else. But sometimes you want to keep a project for you and for your teammates and all kind of configurations and all that. So yeah, let's create a collection here to keep all that grouped. So the collection is pet store, and let's create first request just to get the cat pet by ID. So probably this. Oops. The new request, get pet by ID, and this is the get, of course. And let's take this part of the URL, and then let's see what's the rest of the URL, which is /API/version3. So /API/version3. Perfect. And what else do we need? Okay, so this is kind of placeholder for the ID. So API/version3/pet/PID. So let's go on. So /pet/1 and call it, and this is it. So you may as well say it's not too much magic on it. You can just do it here. That's fine. Yeah, you can do it here. Just
You
take
can
it.
also start the whole Swagger thing and import no code management.
Yeah, true. Exactly. But that's for the next. Yeah, definitely. And now let's do one for create a pet at request. So create, and this is that add a new pet to the store. So let's go the URL from here. So it's just pet, yeah. And maybe let's get example, like if we want to know formally what do we need to send, this is the schema. So we know exactly what can we send and what's mandatory, what not, and the data types. But we can also just take this example, paste it here. Okay, so we need to, it's a post. It's a post. So it has a body and row and format JSON. And we paste this here. And the name is my doggy. ID 101. Terrible name. 101. Let's say, I don't even know. Send. And yeah, I created my doggy, and I can later retrieve it. It won't work because this is all fake, so it won't work. Yeah, I think this is it. Yeah, you can also take this.
Yeah, there's usually like a JSON or a
Where is it? Where is it?
So just under the Swagger
Under the heading?
Yes, here.
Yeah.
Exactly.
right there. You can just drop that URL.
Yeah.
And go to what's one that click on the app.
Import? No.
There you go. And just do the link.
Yeah, the link.
Where?
You click on it before.
You put that
Link. Yes. Boom.
in,
Perfect.
and then you can create it. Yeah, but it takes you to instead of like wizard, and it creates all the requests for you based on your based on your open spaghetti.
And
That's
boom.
pretty handy. Nice.
Everything is there now.
And if your Swagger includes sample requests, Postman will create the sample requests for you to Swagger. Yeah.
Yeah.
Nice.
Great.